Today we're going to learn about inequalities. Our goal is to represent real-world scenarios with inequalities. Today we're going to use a number line to represent them as well. So what is an inequality? Well, an inequality says that two values are not equal. An example of that can be something like having more than $2 or having a budget of $50, meaning you can spend $50, but you can also spend anything less than that, $1, $2, $3, $49, etc. And there's different symbols we use for inequalities. So, A is not equal to B, of course, is represented by the first symbol that you see on the top, here. There are other special symbols that show how things are not equal. So, for example, A is less than B. We remember, hopefully, from previous lessons, the crocodile eats the greater number, of course, being B. A is greater than B. Again, crocodile is eating A because it's greater. And these are some that are new to you, probably. A is less than or equal to B is represented by this symbol. You can see that it's same, but it has this little line at the bottom. That line means that it can also be A. In other words, if you have a budget of $50 or less, you have A is less than or equal to B. And then, of course, greater than or equal to B, of course, means it can be A, but it has to be something bigger as well. It can't be anything smaller. So, it's always important to notice that an inequality represents more than one solution. Make sure you're carefully writing down these symbols and what they mean in your notes. Let's look at an example. So, Layla went to the museum. The scientist told her that these snakes need to be kept warm because they're cold-blooded. They need to be kept at least 75 degrees. How can we represent this temperature as an inequality? Well, at least 75 degrees means that the temperature can be 75 degrees. And it can be more than 75 degrees. In this case, there are constraints, but we're not going to worry about that for 6th grade. That comes a little bit later. For this intro lesson, we just need to know that it has to be kept at 75 degrees or higher. That means that the temperature, which I might represent with T, is going to be greater than or equal to 75 degrees. Now, a closed circle on a number line. So I'm going to start with 75 degrees. So we'll have 70, 75, 80, 85, 90, etc. So we'll start by giving a symbol for 75 degrees, and we have an arrow that just points because it can go on forever. In this case, of course, it would have to stop because you can't keep a snake too hot. And an open circle means that it is not including that number. Now, in a closed circle, which is what we're going to use in this case, means that it can also be that number. So that means it can be 75 degrees or anything higher. So that's how we represent it with this number line. It's really important that you know that an open circle means it cannot be the number, and a closed circle represents that it can be the number. In other words, if you have that underline underneath it, if it's less than or equal to, it's a filled up circle. If it's just less than, then it's, or greater than, then it's an open circle. That would be a really good symbol to put on your keys. Let's look at another example. So, popsicles. Let's look at what Layla's asking us. My mom says that we need to set the freezer so the popsicles don't melt. At what temperature will the popsicles melt? How can we use an inequality for the temperature we should set for the freezer? Well, looking at this sample, I hope you remember from science that the freezing point is 0 degrees Celsius, or we're going to use Fahrenheit because this is America, 32 degrees Fahrenheit. Now, a popsicle can be kept colder than that, but if it's kept warmer, the popsicles won't be popsicles anymore, and they'll melt. So that means it can be 32 degrees, or anything less. So we have 32. So let's start at 36. So now I have my number line labeled. Now I can graph it. So I'm going to start at 32 degrees. The popsicles can be kept at 32 degrees. So my algebraic expression is going to be P for popsicles is less than or equal to 32. So I can fill in my 32 because it has a line underneath it. It can be equal to. And then it can be any number less than that. So I represent it with a closed circle pointing to the left because I'm going to even get into negative numbers. Go ahead and make sure that you have the number line and the symbol representing this situation. Go ahead and take a minute to pause if you need extra time. Let's look at one more example. There are over $100 worth of seashells here. How would we represent that mathematically? Well, again, there would normally be constraints in this, but we know that the seashells, I'll represent that with an S, is greater than $100. It's not equal to. It says over $100. That means it could be $100.01, but it cannot actually be $100. So I'm going to represent that with an open circle. I'm not filling it in because I don't have that equal sign underneath. And then it's going to go to the right because, again, it's any number greater than $100. So now I've graphed it. Go ahead and take a minute and pause the video if you need to graph this and label it on your own. Now it's your turn. You're going to write an inequality for each situation and represent the inequality on a number line. Remember, open circle can mean less than or greater than. Closed circle, I'll write that down at the bottom, is greater than or equal to, less than or equal to. So anytime you have that line, it's a closed circle. Anytime it's open, you have an open circle. You have a no equal to. So your first scenario, Diego spent more than $20 at the mall. The bus can seat 64 people or less. And Juliana's budget is under $50. Go ahead and take a minute to pause and try these out on your own. In this lesson, you've learned how to represent real-world scenarios involving inequalities with a number line. Again, an important thing to remember, open circle can mean greater than or less than. Closed circle can mean greater than or equal to, or less than or equal to. Knowing those symbols will help you with a lot of upcoming problems you're going to have. Don't forget to use a variable or symbol to represent an unknown number or set of numbers. Another great job today, and keep up the good work.